When Comet SWAN, CSES 2025 R2, was spotted just weeks ago, even seasoned astronomers were stunned. From the edge of the solar system came a glowing green object with an immense tail and an eerie steadiness, no flickering, no disintegration, just a persistent emerald burn. Its sudden brightness and strange spectral readings set it apart from typical comets, suggesting something unusual was powering this glow. SWAN didn't just appear, it announced itself, challenging long-held models about what a comet should look and behave like. For many, the big question isn't just what it is, but why it's here now. If you're still watching, subscribe now. You crave more than answers. You seek what lies beyond. Subscribe now and be part of the few who never stop searching. SWAN's passage within 39 million kilometers of Earth tonight is more than a chance to witness a beautiful sky event. Its arrival coincides with another cosmic visitor, raising speculation about unseen patterns, even cosmic messaging. With a 286-year orbital period, this returning object may be part of a deeper celestial rhythm, a quiet but deliberate reminder that the universe still holds secrets. As SWAN arcs past, it leaves behind more than a visual impression. It opens the door to questions we may not yet have the tools to answer. Tonight, something rare slices through the sky. A green comet, glowing steady, strange and bright, passes close to Earth. It appeared only weeks ago, no warning, no years-long tracking data. Just suddenly, there it was. Comet SWAN, catalogued as CSES 2025 R2, a cold body from the outer dark of our solar system. And it's here now, passing within 39 million kilometers of Earth. It burns in emerald, sharp against the night sky. The glow isn't flickering, it's unwavering. The tail stretches for millions of kilometers, trailing across constellations like a knife across velvet. For those in the southern hemisphere, it's visible after sunset, near Libra, a rare sight for the naked eye, but a brutal mystery for the minds trying to explain it, because SWAN isn't behaving like it should. Comets don't glow like this. They sputter, they fluctuate, they're volatile and chaotic. Chunks of rock and ice blasted by solar wind. But this one's different. Its spectral emissions are stable, too stable. It maintains a luminous equilibrium, as if it's holding together when it should be unraveling. That's not just rare, that's borderline unprecedented. And that's not the only thing that's off. Comet SWAN isn't interstellar, it's bound. Orbital models put its period at about 286 years. That means it's been here before, sometime in the 1700s, and it'll be back again. But here's the thing. No one saw it last time. No record, no account, nothing. Which raises a question no one really wants to answer. How does something that bright, that long-tailed, sneak past us for centuries? It came from the outer Kuiper belt, a place we know little about. A graveyard of icy bodies at the edge of solar influence. And now, without warning, it's screaming through the inner system with a tail long enough to dwarf the distance between planets. That alone is enough to rattle confidence in how well we understand these solar outskirts. But there's more, because SWAN didn't arrive alone. Another object, 3I/a tail, is also passing through, a confirmed interstellar traveler. Unrelated by orbit, unrelated by origin. And yet both appear at the same time, from completely different sectors of the sky. That coincidence? It's pushing the boundaries of probability. Some dismiss it. Others call it cosmic rhythm. A few quietly suggest something deeper, that maybe these aren't just cold objects flying randomly through the void. Maybe they follow a pulse, a cadence, patterns we don't yet understand. Some have even suggested without irony that these events are not entirely unconnected. SWAN's path brought it to perihelion on September 12. It swung past the sun, picked up speed, and now it's slicing past Earth. The fact that it's so visible, so bright, is an outlier. Comets with these orbital periods don't usually come this close, not without significant perturbation. So either it was nudged, or we've underestimated its trajectory all along. And then there's the color. The green hue comes from diatomic carbon, C2 molecules excited by solar ultraviolet radiation. That's not unusual on its own. But the intensity of it is. Spectral analysis reveals that the emissions aren't fluctuating as they should. They're holding, maintaining intensity longer than expected. It's not just beautiful, it's bizarre. SWAN isn't melting down like others. It's not fragmenting, not displaying signs of violent solar heating, it's resisting, holding its form. That's not how comets typically behave, especially when they're this close to the sun. Normally these icy bodies begin to fall apart under the pressure. SWAN, it's holding its line. Smooth, consistent, controlled. For astronomers, this is a goldmine. For theorists, it's a headache. For skywatchers, it's a gift. But it also forces a pause, because if this thing was out there, this bright, this stable, this close to Earth, and we didn't see it until now, what else is waiting in the dark? What else is sliding along long arcs, undetected, until it's too late to do anything but look up? Comet SWAN reminds us how little we actually control, how little we know about our own solar neighborhood. It forces us to reconsider the limits of our telescopes, the gaps in our survey coverage, and the fragility of our certainty. And the timing, again, pulls us back to that uncomfortable coincidence. SWAN and 3I/a tail, one a bound object, returning on a centuries-long loop, the other an alien visitor from another star system. Both visible in the same sky, the same month. One green and eerie, the other distant and quiet. They do not speak the same language. They do not share a point of origin. But they arrive together, and that will sit uncomfortably with those who prefer clean models and clean explanations. We don't know why SWAN stayed hidden until now. We don't know why it's glowing the way it is. We don't know if it's been deflected, disturbed, or if it simply wandered in a way we couldn't track. What we do know is that it's here, and it won't be again for nearly 3 centuries. Tonight, that tail drags across our skies. The southern hemisphere holds the view, it flares against the stars. A piece of the solar system's deep history, set on a return path we don't remember, making itself known in a way no one can ignore. It will vanish again, into the outer dark, back into the cold, no fanfare, no trail to follow, just the memory of what we saw, and the data we managed to capture, and then we'll wait. Decades, maybe centuries, for something like it to return. For now there are questions. Why did it appear now? Why this close? Why so bright? Why so stable? Why in tandem with another cosmic arrival? And the deeper, more uncomfortable question, what else don't we see? Comet SWAN cuts through more than just the sky. It slices through our confidence, through the belief that we've mapped the night, that we've got eyes on everything that matters. Its sudden arrival, so visible, so strange, reminds us that space still owns the element of surprise. The glow will fade, the spectacle will pass, but the questions, they linger. And maybe that's the point. Not every event is meant to be understood, some are meant to be felt, witnessed, absorbed, not explained, because the universe doesn't owe us patterns. It doesn't owe us meaning, but every now and then, it gives us both. And when it does, it feels like a whisper, a signal across time, a flicker of something ancient, something purposeful. We may never know what message, if any, Comet SWAN carries, but we saw it. And maybe that's enough. If this kind of cosmic mystery gets your mind spinning, make sure you like this video, share it with someone who needs to see the sky a little differently tonight. Drop your thoughts in the comments. We want to know what you think about SWAN, about the timing, about the glow. And if you want more deep dives into the wild unknowns of space and the silent riddles the universe keeps throwing at us, hit subscribe. There's a lot more coming. SWAN is already moving on. By the time you hear this, the emerald tail will be thinning, the brightness will start to fade. It'll slip past visibility, back into the black. Astronomers will continue tracking it, feeding new data into orbital simulations. The models will adjust, refine, reproject. But no matter how much we learn in hindsight, we can't change what SWAN already revealed. The sky is not silent, it's active, layered, moving, alive with cycles we only pretend to understand. And tonight was a break in the pattern, or maybe the revelation of one we hadn't noticed. This comet didn't come with fanfare, it came with questions, hard ones. Questions about how well we know our own solar system, about what kinds of bodies exist in the Kuiper belt, and how often they cross into the inner sanctum of the sun, about whether gravitational nudges from unknown sources, rogue planets, massive objects in the outer dark, are more common than we'd like to admit. And there's a reason this comet hit harder than most. It's not because of size, It's not even just the brightness, it's the stability. That cold, consistent signature. It didn't break apart, didn't pulse or flare, it just glided forward like it knew exactly what it was doing. That isn't normal. Not for an icy body flung in from 50 AU out. We're taught to think of comets as chaotic. Dirty snowballs tumbling and disintegrating under solar pressure. That's the model. It works until it doesn't. And SWAN didn't. Its emissions didn't flicker, its coma didn't expand wildly, its tail was too neat, too refined. Comet tails are supposed to be shaped by solar wind blown like smoke. SWAN's looked more like a banner. A consistent stream, and that green. That brilliant green. Not just rare, unnervingly pure. Spectral data says it's mostly C2 molecules. Diatomic carbon. You've seen it before in other comets, but not like this. Not with this kind of persistent intensity. Most comets flare green only near the sun, and only briefly. SWAN kept glowing. Through perihelion, through its closest approach. The consistency is not just uncommon, it's a red flag. Because consistency in a comet means one of two things. Either we've fundamentally misunderstood its composition, or there's something stabilizing it. Something we haven't accounted for. Some unknown mechanism inside the comet's body, or around it. Now are we saying this comet is artificial? No, but we are saying that we've underestimated the diversity of these objects. Mass density, composition, behavior, longevity. These aren't standard variables anymore. Every time a new body like SWAN appears, it forces us to reset assumptions, and this isn't happening in isolation. The overlap with 3I/ATLs might be coincidence. But let's define coincidence. Two bright, fast-moving, highly unusual celestial objects, appearing within weeks of each other, one interstellar, one from deep solar orbit. Different vectors, same window. That's not just rare. That's uncomfortable. It's the kind of coincidence that would be laughed off in fiction. But in space, it happened. And if that doesn't get your attention, you're not paying attention. Because this isn't the first time something strange has arrived unannounced. In 2017 we had Umusamo, another interstellar object. Long, thin, accelerating oddly as it exited the system. Then came Borisov, then ATLs, and now SWAN. The tempo is increasing. Not in some supernatural way, in a way that suggests we are finally reaching a threshold in detection. And the unknowns are arriving faster than our models can evolve. That's not a crisis, but it is a recalibration. SWAN wasn't supposed to exist like this. That's the core of the discomfort. We didn't expect it. We didn't see it coming. And now that it's here, it's breaking the rules we thought were universal. Long-period comets are supposed to be fragile, chaotic relics. But SWAN is composed, unbroken, assertive. That forces us to re-examine the Kuiper belt, not as a graveyard, but as a staging ground. A realm of complexity, and maybe even purpose. Because if bodies like SWAN are forming, evolving, or being perturbed in that region, we've been underestimating its activity for decades. And if there are more like it, on similar long arcs, we're going to see them again. Not in centuries. Sooner. Here's where it cuts even deeper. We don't just map rocks in space to marvel at them. We map them because trajectory matters. A comet that comes within 39 million kilometers this time, could come closer next time. And if its behavior doesn't match predictions, we don't know what it'll do 286 years from now. Or 143 years, if it gets perturbed into a shorter orbit. We need to know more. Now. That green light flashing across southern skies isn't just beautiful. It's a reminder that we are still at the mercy of dynamics we don't fully grasp. That ancient ice can surprise modern minds. That for all our probes and telescopes, the sky still writes its own rules. And people are paying attention. Observatories in Chile, Australia, South Africa, they've all focused lenses on SWAN, hoping to catch the last high-resolution data before it fades. Spectrometers analyzing its tail. Infrared scopes, looking for internal structure. Ground-based teams cross-checking orbital path with gravitational models. Because we may not get another chance. SWAN won't be back in our lifetimes. Not unless something changes. Not unless the unseen forces out there bend its arc again. Until then it becomes a data point, a file, an anomaly. But it also becomes something more, a symbol, of how little we know, of how much we have left to learn, and of how quickly certainty can dissolve in the face of reality. The public might forget it within weeks, but those who study the sky won't. Because SWAN exposed a gap between what we think we know and what's actually out there. And that gap is wide. It makes you wonder what else is coming. What else is hiding just beyond our reach? What other coincidences are waiting for us to notice them? Not every answer will come fast. Not every observation will make sense. But every anomaly is a signal. Every unexplained behavior is an invitation to look closer, to question harder, to stop assuming that the universe is quiet. Because it isn't. And if you're the kind of person who stays up late staring at a night sky that never sits still, then you already understand why this matters. Why a green comet flying past at 39 million kilometers isn't just a light show, it's a message. Maybe not in words. Maybe not in language. But in presence. In timing. In the way it forces your mind to reach further. SWAN is fading now. Soon it will vanish entirely. And once again the sky will seem still. But we'll know better. We'll remember that it came. Bright. Strange. Uninvited. And left behind more questions than it answered. Here's the part no one likes to admit. For all the satellites we launch, for all the AI-enhanced telescopes, scanning the sky every second of every day, we're still missing things. Big things. SWAN proved it. It didn't just appear, it appeared suddenly. Bright. Developed. Already active. No slow ramp-up. No distant heads-up. Just boom. One day it wasn't there. The next it was lighting up southern skies with an emerald blaze and a tail that stretched across constellations. And that tail, it's not just a trail of dust and gas, it's a timeline. A chemical signature. A forensic map of where it's been, and what it's shedding as it bleeds into the void. Scientists will parse that tail for months, maybe years, trying to make sense of its consistency, its molecular spread, the eerie uniformity of the emissions. Because they don't match what we thought we knew. The standard comet model, SWAN steps outside it. You can't just slap Kuiper belt object on it and walk away. Because Kuiper belt objects aren't supposed to behave like this. They're supposed to be frozen relics. Fractured. Unstable. Half forgotten by time. SWAN isn't any of those. It's bright. Bold. Composed. Almost too composed. This is where things get uncomfortable. Because when behavior doesn't match theory, there are only two paths. Either the theory needs updating, or the object is doing something we can't explain. And neither option gives comfort. The orbital period, 286 years, suggests this isn't a one-time visitor. It's a local. It belongs to us. Which raises another problem. Why don't we have a record of its last pass? Did it come too far from Earth last time? Was it missed because of bad timing or poor visibility? Or did something change in the interim? Because it's not just where it came from, it's how. SWAN's trajectory, its luminous behavior, even the way it responded, or didn't respond to solar radiation, none of it fits neatly. And when you pair that with the recent appearance of 3I/ATL, an interstellar interloper from a completely different direction, the pattern gets harder to ignore. Separate objects, separate origins, same moment in time, one from the deep cradle of our own solar system, the other from outside the family entirely. It's like watching two ancient messengers cross paths on a road you didn't even know existed. No collision, no interaction, just proximity. Enough to raise suspicion, enough to make you look twice. And if you're the kind of person who shrugs and says it's just chance, think again. Space doesn't usually do theater. It doesn't bother with spectacle. So when two high-profile objects light up our skies within weeks of each other, one stable, one silent, it forces the question, are we witnessing a rhythm we don't yet understand? Because the timing isn't the only thing off. It's the behavior, the composure, the intensity. SWAN wasn't erratic. It didn't behave like an object under stress.
That tail didn't whip wildly. That coma didn't boil and fragment. It was controlled. Precise. Like it knew exactly what it was doing. No, it's not artificial. But it is unnatural in its predictability. And that matters. Because predictability in space is usually earned. It comes from data. From consistency over time. Not from sudden arrivals with unknown properties and unmatched spectral data. SWAN isn't just a new comet. It's a new challenge. A pushback against our certainty. A counterpoint to our confidence. And the irony, we only noticed because it got close. 39 million kilometers sounds like a lot, but in astronomical terms, that's tight. If it had passed just a little farther out, we might have missed it entirely. No spectacle, no data, no questions. Just another silent traveler moving through the dark, unrecorded, unremarked. What does that say about our coverage? About the gaps in our planetary defense systems? We like to think we've got a solid handle on near-Earth objects. But SWAN wasn't even a threat, and we barely caught it in time to study it properly. What if it had been a few degrees off? What if its trajectory had shifted? These are the kinds of thoughts that keep defense analysts awake at night. Because space isn't just wonder, it's vulnerability, it's exposure, and every object we miss is a reminder that we still live under the sky, not above it. And tonight, as it drifts past Earth and slides back into the depths of space, Comet SWAN leaves behind more than a memory. It leaves a scar, a mark, a data signature that will ripple through scientific journals, defense briefings and theoretical models for years to come. There will be attempts to explain it, attempts to normalize it, to tuck it back into the comfort of known categories. But those who felt this event, who saw that green blaze with their own eyes, they'll know better. Because sometimes the universe speaks clearly, not with words, not with intent, but with timing, with juxtaposition, with the kind of eerie symmetry that makes you question what's really random. SWAN's passage will be forgotten by most, a line in a logbook, a brief note in an archive, but for a small number of people, it'll become a point of fixation, a data set that doesn't fit, a moment when the sky said something different. And maybe that's the value, not just in what we saw, but in what it shook loose. The next time something glows green in the night, we'll remember this. We'll look a little harder, react a little faster, we'll ask better questions. Because Comet SWAN wasn't just a curiosity, it was a signal, a reminder, that we're not done discovering this solar system, that our models are still young, that the frontier isn't gone, it's above us. And it still has surprises to send. If you've made it this far, it means something in you still looks up, still wonders, still listens. So go ahead, like this video, if you felt that shift, share it if you think others need to hear what really passed by us tonight. Comment with your thoughts on SWAN, on cosmic patterns, or just what it made you feel. And if you want more stories like this, real, raw, unfiltered truths from the edge of known space, subscribe. We're not done watching the sky, and neither are you.